Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through a course called as Rapid Revision course for KCET 2025. In these videos, I am revising the concepts, shortcuts as well as formulas of the entire chapter in one video. So you will find only the concepts as well as the formulas and shortcuts in these videos. I am not solving the MCQs here. So this is the fourth video in this playlist. So electric charges in field is completed, electric potential and capacitance ಎರಡು ಪಾರ್ಟ್ ಒಳಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. And this is current electricity. Current electricity completely will complete in this video. ಈ ವಿಡಿಯೋದಾಗ full complete ಆಗಿ current electricity ಮುಗಿತದೆ. Right? Okay. And as I have told you earlier also, KCET PYQs 5 years, 8 years, 10 years ಈ ತರ PYQs have solved on each chapter of second PUC physics. So the link for the playlist of that KCET PYQs is present in the description box. You can go there and you can watch those videos. And earlier also I have told you, many of you were asking me the MCQs. So MCQs on PDF na nimage video the description ಒಳಗೆ ಕೊಡ್ತೀನಿ ಅಂತ ಹೇಳಿದೆ. So watch that video and go to the description of that video. You will find a PDF of MCQs in which there are questions also, there are solutions also. So practice those MCQs, you will get a very good maturity in solving CET questions, right? So after publishing the video, next day I will put that PDF, right? So wait for one day after the video, you will get the PDF in that description box. So go and check the description box of that respective video, you will get the PDF there and solve those MCQs. Okay, so let us begin then without making delay. Okay, current electricity. Current means we know it is Q by T, rate of flow of charge. According to quantization, Q is equal to N into E by T. N means number of charges and I is equal to dQ by dt. When to use this dQ by dt? dQ by dt can be used whenever current or charge is given in the form of an equation. Q is equal to 4t square plus 3t plus 6. ಈ ತರ ಚಾರ್ಜ್ ಇಕ್ವೇಶನ್ ಫಾರ್ಮ್ ದಾಗ ಕೊಟ್ಟಿದ್ರೆ ಅಂತಂದ್ರೆ ಕರೆಂಟ್ ಫೈಂಡ್ ಮಾಡೋದಿರಪ್ಪ ಅಂತಂದ್ರೆ ಯು ಯೂಸ್ I is equal to dQ by dt. Next, current I is equal to E divided by R plus R. This is the main current in any circuit. ಯಾವುದೇ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ main current which is coming from positive terminal of the battery. To find out that, you have to use this E divided by R plus R, EMF divided by external effective resistance plus internal resistance. Relation between current and drift velocity, I is equal to NEAVD. Here N means it is free electron density. Here N means it is number of charges. Electronic charge, area, cross sectional area, drift velocity. Right? Expression of drift velocity is EV into tau divided by ml. What is tau? Tau is relaxation time. So this is the expression for drift velocity. This is the expression for conductivity. Conductivity is equal to Ne square tau divided by m. Right? Next, mobility. Mobility is drift velocity per unit electric field. Drift velocity per unit electric field. Current density. Current density is current by area. Current per unit area. Next, by Ohm's law, we know very well V is equal to I into R, but Ohm's law is applicable at constant temperature, right? It is not applicable at a very high or very low temperature. It is applicable only for conductors. It is not applicable for semiconductors as well as insulators, right? Okay, in next note, if a graph is given for you where on y-axis voltage is there and on x-axis current is there, then the slope of this graph will give you resistance. Slope of this graph will give you resistance. Slope of VI graph will give you resistance. Right? Okay, in next note, if slope is greater, if VI graph the slope namak jasti ittappa andre, if slope is more, then resistance will be more. If resistance is more, then temperature will be more. If a graph is given to you like this, ee taradhu ಒಂದು graph ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಇಟ್ಕೋರಿ, voltage and current, and there are two lines like this. There are two lines like this. This is T1, this is T2, and angle of this is theta1 and angle of this is theta2. Looking at the graph itself, you will get to know that slope of first line andre theta1 the line ಏನದ ಇದರದ ಸ್ಲೋಪ್ ನಮಗೆ ಸ್ಲೋಪ್ ಆಫ್ ಸೆಕೆಂಡ್ ಲೈನ್ ಕಿಂತನೂ ಜಾಸ್ತಿ ಅದರಿ, right? So slope is greater, so resistance 1 will be greater than resistance 2 and temperature 1 will be greater than temperature 2. If these are reversed, here if current is given, here if voltage is given, then slope will give you reciprocal of resistance in this case, right? Here it is there, okay, reciprocal of resistance. See, if the graph is I versus V, then the slope will give you reciprocal of resistance. If the graph is V versus I, the slope will give you resistance directly, right? Okay, that is all about ohmic graph. Next, resistance. Resistance is equal to rho into L by A. Resistance is directly proportional to length and inversely proportional to cross-sectional area. What is rho? Resistivity, which is dependent on the material of the wire. If you change the material of the wire, resistance will change. Resistivity will change. See, when resistance will change? In case of stretching and compressing, wire ನೀವು stretch ಮಾಡ್ರಿ compress ಮಾಡ್ರಿ ಆವಾಗ ಆ wire ದ dimension change ಆಗ್ತಾವ್ರಿ. Dimension ಅಂದ್ರೆ ಏನೇನು change ಆಗ್ತಾವ? Length will change, cross sectional area will change, radius will change, diameter will change. When you stretch or compress a wire, these many things will change. So if these many things will change, then obviously resistance will change. But what things will not change? Volume will not change, density will not change, right? Idu namagu change agangilla. Rest of the things will change. So in case of stretching and compressing, this is the final formula which you have to apply. Idin bitte matte namagu iveಲ್ಲ simplified adava, shortcuts anta ನಾವು ಅಂತೀವಿ. But this is the final. If change in length is given, you use this R1 by R2 is equal to L1 by L2 whole square. If change in area is given, R1 by R2 is equal to A2 by A1 whole square. If change in radius is given, R1 by R2 is equal to R2 by R1 whole raised to 4. If change in diameter is given, R1 by R2 is equal to D2 by D1 whole raised to 4, right? So this is the main relation which you have to use to calculate the new resistance whenever a wire is stretched or compressed. So remember this formula correctly. See here, length is L1 by L2, area is A2 by A1, radius is R2 by R1 whole raised to 4. These both are whole raised to square, these both are whole raised to 4. See, this is also whole raised to 4. Okay. Okay, so we got to know this much. Well, next, see, if stretching and compressing of wire, we know length, area, radius and diameter will change, volume will remain same. Okay, if in case of stretching, you can use this formula also, R dash equal to n square times of R, right? ಈಗ ನಮಗೆ 2 times stretch ಮಾಡಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ, if a wire is stretched 2 times its original length, then n is equal to 2, so n square will be 4, so 4 times of R it will be there, right? So like that, new resistance you have to calculate. Resistivity of alloys is greater than resistivity of metals or conductors, right? Okay, next we'll go for temperature dependence of resistance. See how resistance changes with respect to temperature. If you increase in conductors, this is in case of conductors. So if you increase the temperature of the conductor, relaxation time will decrease. What is relaxation time? Relaxation time is the time spent in between two collisions of an electron. If electron has collided here, this is the first point of collision, this is the second point of collision. So the time taken from first collision to second collision, that is called relaxation time. So if you increase the time, thermal velocity of the electrons will increase. Thermal velocity means the speed of the electrons will increase. ಯಾಕಂತಂದ್ರೆ ಈಗ ಈ ಫಸ್ಟ್ ಕೊಲಿಜನ್ ದಿಂದ ಸೆಕೆಂಡ್ ಕೊಲಿಜನ್ ಬರ್ಲಿಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ 4 ಸೆಕೆಂಡ್ ಟೈಮ್ ತಗೊಂಡಿತ್ತಪ್ಪ ಅಂದ್ರೆ ಮೊದಲ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚು ಮಾಡಿದ ಕೂಡಲೇ ಅದರ ಸ್ಪೀಡ್ ಹೆಚ್ಚಾಗ್ತದ್ರಿ, ಥರ್ಮಲ್ ಸ್ಪೀಡ್ ಹೆಚ್ಚಾಗಿ 2 ಸೆಕೆಂಡ್ ಒಳಗೆ ಇಲ್ಲಿಗೆ ಬರ್ತದ್ರಿ. ದಟ್ಸ್ ವೈ ವಿ ಸೇ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಟೈಮ್ ಡಿಕ್ರೀಸಸ್. ಸೊ ವೆನ್ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್, ಥರ್ಮಲ್ ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸಸ್, relaxation time decreases, resistance increases, resistivity increases. So indirectly by increasing temperature, resistance increases. Collisions ಹೆಚ್ಚಾಗ್ತಾವ್ರಿ, collisions ಕೂಡ ಹೆಚ್ಚಾಗ್ತಾವೆ. This is what happens when the temperature of a conductor is increased. See, for conductors, semiconductors and alloys, by increasing temperature in conductors, by increasing temperature, resistance increases. That's why temperature coefficient of resistivity is positive. Temperature coefficient of resistivity is positive. In semiconductors, by increasing temperature, resistance decreases, conductance increases. That's why temperature coefficient of resistance is negative. In alloys also, by increasing temperature, resistance increases. That's why alpha is positive. Temperature coefficient of resistance, alpha is positive. Here alpha is large. See, here also alpha is positive. Here also alpha is positive. But here alpha is large and here alpha is small. Resistivity of alloys is very high. That's why it is used in constructing the resistance boxes, right? Its resistivity is very high. Alpha is small, but resistivity is high. This is temperature dependence of resistivity. See, next, if the temperature has got rise from 0 to higher temperature, 0 to 20, 0 to 30, 0 to 80, like this, if we are increasing the temperature from 0 to higher temperature, at 0, absolute 0, the resistances are not. At higher temperature, the resistances are. When the situation is from 0 to higher temperature, you use this formula, R is equal to R naught into the bracket 1 plus alpha T, where alpha is temperature coefficient of resistance, right? R naught is the resistance at 0, absolute 0, R is the resistance at higher temperature. Okay, if the temperature has not got rise from 0 to higher temperature, if the temperature has got rise from one temperature to another temperature, for example, 10 to 40, 20 to 80, like this, from one high temperature to another high temperature, if the temperature has increased, at temperature T1, the resistance is R1, at temperature T2, resistance is R2. In this case, if you are asked to calculate alpha, use this formula. Alpha is equal to R2 by R1 divided R2 minus R1 divided by R1 into T2 minus R2 into T1. Use this formula to calculate alpha only. Next, in the same case, if T1 is given, R1 is given, T2 is given, R2 is asked, athwa T1 is given, R1 is given, R2 is given, T2 is asked, use this formula to calculate, right? E formula use madri. R1 divided by R2 is equal to 1 plus alpha T1 divided by 1 plus alpha T2. Use this formula to calculate that. Next, if you take resistance versus temperature graph, it will be straight line and the slope of the straight line will be constant. So slope of resistance versus temperature will be change in resistance upon change in temperature. This will be constant. Slope everywhere will be constant. Here also it is same, here also it is same, and here also it is same. So slope will be constant, right? Slope of resistance versus temperature graph. Okay, next, electric power and energy. See, the formula for electric power is V into I, V square by R, athwa I square into R. This is the formula for electric power. Electric energy, power into time. Energy means power into time. So you can multiply time for all these formulas. Vi into T, V square by R into T, I square into R into T. Right? Okay, 1 kilowatt hour power is equal to 3.6 into 10 raised to 6 joule. 1 horsepower is equal to 746 watts. 746 watt. Okay, ಈಗಲೇ ನೋಡ್ರಿ ಈಗ ನಿಮಗಿಲ್ಲೇ ಬಹಳಷ್ಟು ಕ್ವೆಶ್ಚನ್ಸ್ ಒಳಗೆ ಇವು ಕನ್ಫ್ಯೂಷನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾವ್ರಿ. ಸೊ ಯು ಶುಡ್ ನೋ ದಿಸ್ ಕ್ಲಾರಿಟಿ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ. See, we have a bulb here. A bulb ಮೇಲೆ marked power and marked voltage ಅಂತ ಇರ್ತಾವ್ರಿ. For example, if you go and ask a bulb in a shop, ಈಗ ಯಾವುದೋ ಒಂದು ಶಾಪ್ ಹೋಗಿ ನೀವು ಬಲ್ಬ್ ತಗೊಂಡ್ ಬರ್ಬೇಕಿತ್ತಂದ್ರೆ they will ask you ಎಷ್ಟರದ ಬಲ್ಬ್ ಬೇಕಂತೇಳಿ. It means they are asking you what power you want. ಅಂದ್ರೆ ಎಷ್ಟು ಪವರ್ದ ಬಲ್ಬ್ ಬೇಕು. ಸೊ ಆ ಬಲ್ಬ್ ಮೇಲೆ ಪ್ರಿಂಟ್ ಹಾಕಿರ್ತಾರ್ರಿ. Okay, so the values which are printed on the bulb are called marked power, marked voltage. ಅದಕ್ಕೆ ಹೆಸರು ಮಾರ್ಕ್ಡ್ ಅಂತ ಕರಿಬಹುದು, ಸ್ಪೆಸಿಫೈಡ್ ಅಂತ ಕರಿಬಹುದು. Like that they can tell it, right? So different words they will use in the question. So P0 and V0 indicates the marked power and marked voltage which are printed on the bulb. Correct? And next, P and V are actual power. ಇದಕ್ಕೆ ನೋಡ್ರಿ, ಇದು marked power. ಇದಕ್ಕೆ actual power ಅನ್ಬೋದು, output power ಅನ್ಬೋದು, brightness ಅನ್ಬೋದು, true power ಅನ್ಬೋದು, power dissipated ಅನ್ಬೋದು. These many different names it has. Right? See, for example, if there is a bulb whose marked power is 100 watt, whose marked power is 100 watt, and whose marked voltage is 220 volts. Now, if this bulb is connected to a battery, of 110 volts, right? If it is connected to a battery of 110 volts, then this bulb will not give you an output power of 100 watt. ಯಾಕಂತಂದ್ರೆ ಅದಕ್ಕೆ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟರೆ 100 ವ್ಯಾಟ್ ಕೊಡ್ತದ್ರಿ. ಅದು 220 ವೋಲ್ಟೇಜ್ ನೀವು ಆ ಬಲ್ಬ್ ಕೊಟ್ಟರೆ ಆ ಬಲ್ಬ್ ನಿಮ್ಗೆ 100 ವ್ಯಾಟ್ ಬೆಳಕು ಅಥವಾ ಬ್ರೈಟ್ನೆಸ್ ಅಥವಾ ಔಟ್ಪುಟ್ ಪವರ್ ಕೊಡ್ತದ್ರಿ. ಸಿನ್ಸ್ ಯು ಹ್ಯಾವ್ ಗಿವನ್ ಲೆಸ್ ವೋಲ್ಟೇಜ್, ರೈಟ್? ಅದ ವೋಲ್ಟೇಜ್ ನಾವು ಇಲ್ಲಿ ಬರ್ತೀವಿ ನೋಡ್ರಿ. Since you have given less voltage, the actual power of that will be less than 100 watt. So it may be 60 watt. So what is this 60 watt? This is actual power. ಅಲ್ಲಿ actually ಆ ಬಲ್ಬ್ ನೀವು 100 ವೋಲ್ಟ್ ಸಪ್ಲೈ ಕೊಟ್ಟಾಗ ಆ ಬಲ್ಬ್ ಎಷ್ಟು ಔಟ್ಪುಟ್ ಅನ್ನು ಕೊಡ್ತಿರ್ತದೆ, ಎಷ್ಟು ಬೆಳಕನ್ನು ಕೊಡ್ತಿರ್ತದೆ, that is actual power. Marked power is different, actual power is different. Marked power ಅಂದ್ರೆ ಏನಾಗ್ತದೆ, ಲಿಮಿಟೇಷನ್ ರೀ. 220 ವೋಲ್ಟ್ ನೀವು ಕೊಡ್ರಿ, 100 ವ್ಯಾಟ್ ಪವರ್ ಅದು ಡಿಸಿಪೇಟ್ ಮಾಡ್ತದ್ರಿ. That's it. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಕೊಟ್ಟರೆ ಕಡಿಮೆ ಕೊಡ್ತದ್ರಿ. So that is actual power, that is marked power. And one more important thing what you should know in marked power is V0, marked voltage ಏನದಲ್ಲ, if you give the voltage more than that voltage to that electrical instrument, it will get fused, it will get burnt. ಅಂದ್ರೆ ಈ ಬಲ್ಬ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೋಲ್ಟೇಜ್ ಎಲ್ಲಿ ತನಕ ಅದು ಕೆಲಸ ಮಾಡ್ತದಪ್ಪ ಅಂದ್ರೆ 220 ವೋಲ್ಟ್ ತನಕ ಕೆಲಸ ಮಾಡ್ತದೆ. If you give voltage less than 220, it will work, but output power will be less, right? ಬೆಳಕು ಕಡಿಮೆ ಕೊಡ್ತದ್ರಿ. If you give voltage greater than 220 volt, that bulb will get burnt, it will get fused, right? So that is the meaning of marked voltage and marked power, actual power and actual voltage. Correct? Okay, so we got to know the difference between marked power, marked voltage, actual power, actual voltage. Next note, use marked power and marked voltage only to calculate the resistance by this formula. ಈ ಮಾರ್ಕ್ಡ್ ವೋಲ್ಟೇಜ್ ಮತ್ತು ಮಾರ್ಕ್ಡ್ ಪವರ್ ಆ ಬಲ್ಬ್ ಅಥವಾ ಗೀಸರ್ ಅಥವಾ ಹೀಟರ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ರಿ. ಆಕ್ಚುಯಲ್ ಪವರ್, ಔಟ್ಪುಟ್ ಪವರ್, ಬ್ರೈಟ್ನೆಸ್, ವಾಟ್ ಎವರ್ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ V square by R. ಡೋಂಟ್ ಯೂಸ್ ಮಾರ್ಕ್ಡ್ ವೋಲ್ಟೇಜ್ ಹಿಯರ್. ಇಲ್ಲಿ ಮಾರ್ಕ್ಡ್ ವೋಲ್ಟೇಜ್, ಮಾರ್ಕ್ಡ್ ಪವರ್ ಯೂಸ್ ಮಾಡಬೇಡ್ರಿ, ರೈಟ್? ರೆಸಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿರ್ತೀರಿ, ದಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯು ಟೇಕ್ ಹಿಯರ್, ರೈಟ್? ಪವರ್ ಬೇಕಾದ್ರೆ ಆಕ್ಚುಯಲ್ ಪವರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟಿರ್ತಾರೆ 110 ಅಂತ ಕೊಟ್ಟಿದ್ರೆ, ದಟ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಹಿಯರ್, ರೈಟ್? ದಟ್ಸ್ ಆಲ್ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪವರ್ ಅಂಡ್ ಎನರ್ಜಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಬಲ್ಬ್ಸ್ ಇನ್ ಸೀರೀಸ್ ಅಂಡ್ ಬಲ್ಬ್ಸ್ ಇನ್ ಪ್ಯಾರಲಲ್. ಓಕೆ, ಈ ಕೇಸ್ ಒಳಗೆ ನೋಡ್ರಿ, series combination idre effective power will be 1 by ps equal to 1 by p1 plus 1 by p2, similar as that of capacitors in series or resistors in parallel, right? You can write this as like this also, ps is equal to p1 into p2 divided by p1 plus p2. You can write it like this also, right? Okay, next step. See, marked power, resistance and actual power, the relation is like this. Marked power is inversely proportional to actual power. Marked power is inversely proportional to resistance. Where? In which combination? In series combination. In bulbs in parallel, marked power is inversely proportional to resistance. Marked power is directly proportional to actual power. So one the common other, marked power is inversely proportional to resistance. This is common. In series, marked power is inversely proportional to actual power. In parallel, marked power is directly proportional to actual power, right? So this is the difference, right? in nodri effective power in parallel will be P1 plus P2, effective power in parallel. Okay, next we'll go for further concept now. Cells related concept. See, this is open circuit. Why it is called open circuit? Because there is no continuous connection from positive terminal of the battery to the negative terminal of the battery. So open circuit ittandre atrolage current namaga zero irtadri. Current zero idre resistance infinite irtadri. So resistance is infinite, current is zero. And in this case, the potential difference between the terminals of the battery, a battery the positive negative terminal nಡುವೆ the potential difference ಏನಿರುತ್ತದೆ ಅದಕ್ಕೆ terminal potential difference ಅಂತ ಕರೀತಾರೆ. That terminal potential difference will be equal to EMF of the cell. EMF of the cell. It means we can define EMF like this also. EMF of the cell is the potential difference between the terminals of the cell when it is in open circuit, right? Okay, in closed circuit, when there is closed circuit means there is a continuous connection from positive to negative terminal of the battery, correct? In closed circuit, the potential difference between the terminals of the cell V will be equal to E minus IR. Terminal potential difference anta ಕರಿತೀವಿ ಅದಕ್ಕೆ. Terminal potential difference V is equal to E minus IR, right? Okay, and I will not be equal to 0. There will be I flowing in the current circuit and R is not equal to infinity. ಇದಕ್ಕೆ terminal potential difference ಅಂತ ಕರೀತಾರೆ. For example, ಈಗ ನೋಡ್ರಿ. Okay, fine. That is all about the terminal potential difference of the cell in closed circuit. Closed circuit ಒಳಗೆ ಒಂದು cell the terminal potential difference E minus IR ಇರ್ತದ್ರಿ. For example, ಈಗ next ನೋಡ್ರಿ. If there are two cells like this, we know current is always shown out from positive and inwards to the negative. See, if this is of 100 volt, and if this is of 50 volt, then in this circuit, current you should show in this direction or current you should show in this direction. Yav direction to ತೋರಿಸಬೇಕು, right? So ಈ ಕಡೆಯಿಂದ ನೀವು ಹೊರಗಡೆ ತೋರಿಸಿದ್ರೆ this is correct for this cell, it is coming out from positive. ಇದಕ್ಕೆ ನಮಗೆ ಮತ್ತೆ ಪಾಸಿಟಿವ್ ಇನ್ವರ್ಟ್ಸ್ ಹೋಗ್ತದೆ. ಈ ಕಡೆಯಿಂದ ತೋರಿಸಿದ್ರೆ this is correct for this cell, but ಈ cell ಗೆ ಇನ್ವರ್ಟ್ಸ್ ಹೋಗ್ತದೆ. So you should decide on the voltage, which cell is having more voltage, that is said to be dominant cell, and the current will flow according to that dominant cell, right? Okay, see here you can observe the current is coming out from the positive terminal of the cell. If the current is coming out from the positive terminal of the cell, it is called discharging cell. It's a potential difference, its terminal potential difference will be E minus IR. If the current is flowing inside the positive terminal of the cell, it is said to be in charging mode, and its a terminal potential difference will be E plus IR, right? That is the difference. So if the current is coming out from positive, E minus IR. If current is entering inside the positive, E plus IR, terminal potential difference. Okay, next combination of cells we'll see. We know very well, if the cells are connected in series, then equivalent EMF will be equal to E1 plus E2. Equivalent internal resistance will be R1 plus R2. If identical cells are there, E equivalent is equal to N into E. R equivalent is equal to N into R, right? So these formulas we know it from theory itself, so you have to remember those formulas. Cells in parallel. Okay, E equivalent is equal to, if two cells are connected in parallel, equivalent EMF will be equal to E1 R1 plus E2 R2 divided by R1 plus R2. Equivalent internal resistance will be equal to R1 into R2 divided by R1 plus R2. Parallel the formula, right? Parallel effective resistance formula. If identical cells are in parallel, ಇದು ಒಂದು ಕರೆಕ್ಟ್ ಆಗಿ ನೆನಪಿಟ್ಕೋರಿ. ಇಲ್ಲಿ ನಮಗೆ n into E ಅದ ಅಂತ ಹೇಳಿ E divided by n ಅಲ್ಲ, it is E only. Whatever number of cells may be in parallel, if the cells are identical, effective equivalent EMF in that parallel combination is always E. So you remember this clearly, right? ಯಾಕಂತಂದ್ರೆ ನೋಡ್ರಿ, capacitors in parallel CP, identical capacitors in parallel, CP is equal to C by N. Series, identical capacitors in series, CS is equal to C by N. Identical capacitors in parallel, CP is equal to N into C, right? Ali C by N adare series ಒಳಗೆ. Identical resistors in parallel, R by N. But identical cells in parallel, it is not E by N, it is E. Resistance is R by N only. R equivalent is equal to R by N, correct? Okay, next. See, this is mixed grouping of cells. Mixed grouping of cells means there are identical cells which are connected in series also and which are connected in parallel also, right? Number of rows here is taken as M, and number of cells in each row is taken as N. So the current which is flowing from this mixed combination is calculated by using the formula Mn into E divided by Mr plus Nr, where M is number of rows, N is number of cells, right? And for for maximum current, see, this is not the condition. For maximum current, Mr must be equal to Nr. Mr must be equal to Nr for maximum current from this circuit. Total number of cells calculate ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ M into N, total number of cells. Next, here equivalent EMF. ಇಲ್ಲಿ ನೋಡ್ರಿ, there are N cells, N identical cells in series. So one row the effective EMF ಎಷ್ಟಾಯ್ತು? One row the effective EMF ಎಷ್ಟಾಯ್ತು? N into E. So this row n into e, this row n into e, this row n into e. So n into e, n into e, n into e parallel. So parallel ಒಳಗಿದ್ದಾಗ n into e ನ ಅದರದ effective resistance ಇರ್ತದ್ರಿ. E equivalent is equal to n into e. Equivalent resistance n into r divided by m, number of rows, right? So this is how we have to find the current in the mixed combination of cells. Next, there are few more, there is one more concept related to the cells. See, E1, E2, E3, there are 3 cells connected in series. 3 cells namagil series ಒಳಗದಾವ್ರಿ. You can check here, first cell is positive negative, second cell positive negative, third cell negative positive. So third cell is wrongly connected here. This is wrongly connected cell. So in this case, equivalent EMF will be equal to E1 plus E2 minus E3. E1 plus E2 minus E3. Wrongly connected cell EMF now minus ತಗೊಳುತ್ತೆ. But resistance minus ಮಾಡೋಂಗಿಲ್ಲ, resistance plus ತಗೋಬೇಕು. Whether it is correctly connected or wrongly connected, resistance is going to be applied by that battery, by that cell. So equivalent resistance will be R1 plus R2 plus R3. Correct? So ಈ ತರ ನೀವು ಅದನ್ನು ತಗೋಬೇಕು. Next, for identical cells, ನೋಡ್ರಿ, that is for non-identical cells. Non-identical cells wrongly connected, minus E3 ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. See, for identical cells, E equivalent is equal to n minus 2m into E. N is total number of cells, m is number of cells connected wrongly. Number of cells connected wrongly, m, correct? And R equivalent will be equal to n into R. So equivalent EMF when in identical cells, when some cells are connected wrongly, n minus 2m into E. N is total number of cells in series. Total number ಅಂದ್ರೆ ಅದ್ರೊಳಗೆ correctly connected ಆಯ್ತು, wrongly connected ಆಯ್ತು, ಎರಡು ಕೂಡಿನರಿ. m ಅಂದ್ರೆ ಬರೀ wrongly connected cells, right? Okay, that is all about the cells. Next, balancing condition of Wheatstone's network, P by Q is equal to R by S. If this is balanced, if LH is equal to RHS, then IG will be equal to 0. Then IG will be equal to 0. Current in the galvanometer will be 0. See, if the circuit is like this, if the circuit is like this, this is R1, let me say R1, this is R2, this is R3, and this is R4, and this is R5. This is R5, right? So, ಇದು ನಿಮಗೆ ಈ ತರದ ಸರ್ಕ್ಯೂಟ್ ಬಂದಾಗ ಎಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾದರೂ ನಿಮಗೆ ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ, if effective resistance is asked to calculate, first check whether it is balanced or no. First check whether it is balanced or no by applying the formula P by Q is equal to R by S. R1 by R2 is equal to R3 by R4, right? If it is balanced, you can neglect this cell. Sorry, you can neglect this resistance. E resistance ನೀವು ಬಿಟ್ಟುಬಿಡ್ರಿ, you remove it, right? At that time you will get to know the combination now. R1 and R3 will be in series. ಈ R1 3 ಅಂತ ನೀವು ತಗೋಬಹುದು. R4 and R2 will be in series. ಇದು ನೀವು R2 4 ಅಂತ ತಗೋಬಹುದು. R1 3 and R2 4 will be in parallel. ಅದನ್ನ ಆಡ್ ಮಾಡ್ಕೊಂಡು ಬಿಡಬಹುದು, right? Next, by changing battery and galvanometer, network remains balanced, no changes happen. ಅಂತಂದ್ರೆ ಈಗ ನಾವು ಇಲ್ಲಿ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ಇಲ್ಲಿ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ಇಲ್ಲ ಗ್ಯಾಲೋನೋಮೀಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. So if I connect battery here and if I connect galvanometer here, no changes will happen. It will remain balanced only. ಅದು ನಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಆಗಿನೇ ಉಳ್ಕೊಂತದ್ರಿ, right? So that is all about the Wheatstone's network. Wheatstone's network the ಮತ್ತೊಂದು ಫಾರ್ಮ್ಯಾಟ್ ನಾನು ನಿಮಗೆ ಇಲ್ಲಿ ತೋರಿಸ್ತೀನಿ. I will show one more format of Wheatstone's network here. This also indicates the Wheatstone network only, right? Okay, see, this is the Wheatstone's network. This is the Wheatstone's network, right? Okay, so this is said to be P, this is said to be Q, this is said to be R, this is said to be S. P by Q is equal to R by S ಇತ್ತಂದ್ರೆ you forget this. ಇದನ್ನ ಮರ್ತು ಬಿಡ್ರಿ, ಅವಾಗ P and R will be in series, Q and S will be in series, you will find out the effective resistance. So this is another form of Wheatstone's network. So that's all about current electricity. Dear students, if you like the content of this channel, please don't forget to subscribe the channel, and please don't forget to share the video and share the channel with your friends, right? And dear students, as I have told you already, if you are getting helped with these videos, please don't forget to share the video first thing, and please share your opinion regarding this series so that I will continue the series. My intention is to cover one chapter every day in one video, so that I can cover all the chapters of second PUC at least for you all, right? And ಅದಾಗಿದ್ಮೇಲೆ ಈಗ ಬಹಳ ಜನ ನನಗೆ MCQs ಗಳನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರಿ. ಸೊ MCQs ಗಳನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ I will finish up this series first and then I will start with MCQs. ಎಷ್ಟು ಪಾಸಿಬಲ್ ಅದ ಅಷ್ಟು MCQs, ಅಷ್ಟು ಚಾಪ್ಟರ್ಸ್ MCQs ಗಳನ್ನು ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. And I have told you already, presently I can't solve the MCQs, but if you want, I can give you a PDF of MCQs on each chapter. So ಈ ವಿಡಿಯೋದ ಈ ಚಾಪ್ಟರ್ ಮೇಲೆ ನಿಮಗೆ MCQs ಪ್ರಾಕ್ಟೀಸ್ ಏನಾದರೂ ಬೇಕಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, after one day of publishing this video, you go for the description and you will find a link for the PDF, and you download that PDF. In that you will find question also and answers also, right? Solutions ಕೂಡ ನಿಮಗೆ ಅದರೊಳಗೆ ಇರ್ತದೆ. Okay, well, that's all about current electricity. We'll see further chapter in the next video, moving charges and magnetism, in the next video. Thank you so much. Please keep watching and supporting the channel. Thank you.